Hello everyone and thank you much for watching. This is me, Mr. P, and welcome back to another episode of a Proxmox home server series, or should I say Proxmox Cluster home server series. As in this video, we're going to crank it to 11 and we're going to set up Proxmox Cluster. Before going any further, I want to mention 3 things. Number 1, the best practice to have Proxmox Cluster is with 3 nodes. I have node 1, node 2 and node 3 ready for this video. But you can have Proxmox Cluster running with 2 nodes, and you can have Proxmox Cluster running with 2 nodes plus Q device. Number 1, Proxmox Cluster with 2 nodes will function. You will be able to migrate VMs and LXC containers between 2 nodes. It's not going to be as fast as if you would have 3 node high availability Proxmox Cluster. With 2 nodes Proxmox Cluster, yes, you can migrate VMs and LXC containers, but if one of the node dies, VMs that were hosted on that node will be offline. The Proxmox Cluster will not automatically migrate LXC containers and VMs to a functioning node. With 2 nodes in Q device, the high availability is, you can set up high availability as Q device, which can be anything, even a Raspberry Pi, will act as a voting. The way that the Proxmox high availability works is that each node receives a vote. So it can vote for each other who will take over if one of the node dies. So Q device will act as like a referee who will just give a vote to remaining online node to take over. So if 2 nodes plus Q device, you can set up high availability, but if a Q device dies and one of the node dies as well, basically your Proxmox Cluster becomes dead, no VMs will function and you can't do any migrations. So it's recommended to have 3 node cluster. Number 2 is that you don't need to have 3 nodes exactly the same specification. In my case, I have all 3 nodes with the same amount of CPU, RAM, storage, and each of them has exactly the same amount of hard drive attached to it. But I can easily create a Proxmox Cluster with just one node having 4 CPUs, another node having 8 CPUs. One node can have 4 GB of RAM, another node can have 64 GB of RAM, and the Proxmox cluster will function. But the problem that I will face, that if, for example, my node 3 will have 64 GB of RAM and it will run 12 VMs. And if that node dies, Proxmox high availability will push all these VMs to another node with just 4 GB of RAM. And 4 GB of RAM is not enough to fully host 12 VMs. So it's ideal and it's recommended to have all 3 nodes to be exactly the same specification. But if one node has 8 GB of RAM and another one 16, you need to play around which VM will land to which node once one of the node dies inside a high availability cluster. And number 3, before you set up the Proxmox cluster, you need to note that only one node is allowed to have VMs and LXC containers during the setup process. In my case, for example, if a PVE1 will have 2 VMs running here and PVE2 will have 2 VMs running here, I won't be able to set up Proxmox cluster because during the setup process, Proxmox will moan at me that one of the nodes already hosting VMs and LXC containers. Ideally, you would like to completely wipe all these 3 nodes, do a fresh install of the Proxmox with no VMs and LXC containers running, and then start setting up the cluster. But if you have one node already with the VMs, another 2 are hosting nothing, basically they are blank, the one with VMs needs to be initiator, needs to be the one that is going to start setting up the Proxmox cluster. So let's start setting up the cluster with my 3 nodes. I will pick PVE1 as my initiator, so I will click on a data center, and inside cluster option, I will have 2 options to click. Create a cluster and join a cluster. Because there is no cluster created yet, I need to press create a cluster. And I will click and I will name this cluster Mr. P channel. Here we go. And cluster name is given, and then it automatically picks up my NIC, my IP address that will be used to synchronize all the nodes inside this cluster. If your node has more than one NIC, it's going to show you more IP addresses in here. So I'm going to say everything is fine. I'm going to click create. Oh yeah, because it's not allowing me to do this. Let's do dash instead of underscore. So right now Proxmox is creating the cluster for me, and once the creation is done, I will get a notification saying that the creation is completed, and then I will be able to copy the join token. Here we go, task is done. I'm going to exit that out, and now I can see that there is a cluster created, Mr. P channel, config version 1, number of nodes 1, and this is the node PVE-1, ID number of this node is 1, and the vote, this node received 1 vote. So now I can click join information, and it's going to give me automatically generated join information, which I need to just click on this button, and it will copy all this text block. This text block contains everything that is required for another node to join the cluster. I will click on the node 2. Under data center, I'm going to click cluster, and instead of selecting create cluster, I'm going to click join cluster. And in here, I will paste that command of all that text block. It's automatically pre-filled all the information. And now I need to enter the peer's root password. And this is the password, the root password for my node 1. So I'm just going to go here and enter password for my node 1 and click join Mr. P channel cluster. And this is joining now, and it might feel like this is actually becomes offline. So I can actually close that, go to here, and I can see that under my node 1 tab with the node 1 IP address, right now I can see node 1 and node 2 showing up. This gives me an error that is just there is no connection to PV2 because it's actually doing all these connections in the background. I'm going to refresh this, and here we go. I have PVE1 and PVE2 in my Proxmox cluster. Before I go and join node 3, I'm going to show you what I meant saying about high availability. If we're going to click on the data center for this cluster, I'm going to scroll down in this option list and click on HA, which stands for high availability. If I click on that, right now it says quorum is okay, which is fine. But if I'm going to start creating VMs, I'm going to start setting up availabilities, high availability VMs, I will start getting messages, notification messages, error messages, displaying that a quorum is not okay because only 2 nodes available, and a fully functioning quorum requires 3 nodes. So now I'm going to go back and then back to node 3, data center, cluster, join, paste this same text block, enter the password, root password, not for node 2. We're still using a root password for node 1. And password is in. I'm going to say join Mr. P channel. And again, this might look like it's going offline. I can actually close that. And I can see in the node 1 page, right now I have PVE3, which is node 3 showing up. I will just refresh that. Let's refresh again. And here we go. It's going from a question mark, and it's going to be a green tick in a minute. Here we go. Now I have 3 node cluster. If I'm going to click on a data center and under summary, I can see that there is 3 nodes available, no VMs and no LXC containers running. And if I scroll down, I will gives me a resources. So combined between 3 nodes, I have 12 CPUs, I have almost 12 gigabytes of RAM, and I have 175 plus gigabytes of storage. And it gives me the information per each node. It shows me uptime, memory usage, and CPU usage, and their IP address. Next, we're going to talk about storage. First storage setup I want to show you is called local. Basically, you install the Proxmox OS inside one drive, and that drive is used to run Proxmox OS, host VMs, LXC containers, and store VMs templates and ISO files. As you can see, VM disk located on this side, and if I go to node 2, CT volume is located at this side. So simple setup. All 3 nodes has one storage that is used for everything. So first of all, let's set up high availability, for example, on this VM. If I click on a 100, ID number 100, I will click on more, and I can choose manage HA here, or I can click on a data center, scroll down, select the HA, and I can add it here. As you can see, it's detected that I have 3 nodes, quorum is okay, and the master is being picked up as a PVE2. If one of the nodes dies, other 2 will start voting, and the VMs should automatically migrate. But with local disks being used for storage and everything else, that will not work, and I will show you why. So if right now I'm going to go back in the data center, click on the HA, I will click add, and I want my Alpine VM to be high available VM. I'm going to click on here. You can create the groups. I will show in a second how that works. So that's it. Maximum restart is 1 and maximum relocation is 1. 100, ID number 100, I want a high availability. I'm going to click yes. And now that's it. VM 100 has been added as a high available and is being queued with the state. So technically, if the node 1 will crash, node 2 should pick up the pace and get the node 1 ID number 100 VM running. But it will not work because local disk has no idea that this drive or hard drive for this VM actually exists. If I click on a node 1 under VM disks, as you can see, 6.44 gigabytes drives exist here, but it doesn't exist here. So if this node suddenly goes offline and Proxmox Cluster will start, oh, okay, this node is died. We need to migrate 100 to this node or this node, but wait a minute, they don't have anything here. So there is an option for that to function. If I click on a node 1, ID number 100 VM, I'll click on replication and I'll click add. So I want this node or this VM replicated to PVE2 every minute. But if I click create, it's going to give me an error that this is not going to work on the local storage drive, because local storage is just stores data here and you can't create high availability VMs and LXC containers. Yes, you can migrate stuff between, like for example, if I click on this LXC container, I will right click on this, choose migrate, or I can go and click on this button and I'll say, okay, I want from PVE2 to PVE3. Restart mode means that the LXC container will shut it down, migrate this data, and then start from basically cold. It will restart. I'm going to click create. And what Proxmox Cluster is doing now is shutting down the LXC container 101 and is creating the drive inside node 3 with exact same data that was on a node 2 for that LXC container to function, and is migrating every single block from node 2 to node 3. It will take time depending on the LXC container drive size and VM drive size. As you can see, it's right now going up to, I think this is 6 gigabytes drive. So it's just right now reaching 4.5. It's going to be almost finished in a second. And here we are. This is actually being migrated. 36 gigabytes is actually 8 gigabytes and is completed in, I do believe, 45 seconds. So this in 46.8 seconds. It's migrated the LXC container from node 2 to node 3. So right now node 3, if I click on a local under CT volumes, it knows that this drive exists. And if I click on a PVE2 local CT volumes, the drive doesn't exist here because Proxmox just took everything and migrated all the way to node 3. So just using a local as a storage, high availability is not going to work. Next storage option is ZFS. And right now what we're going to do, we're going to quickly create a ZFS pool in each of these nodes, and we're going to start creating high availability and replication. I'll click on a PVE1, and if I scroll down under disks, I have the one 32 gigabyte drive attached to it. So I can go to ZFS, create ZFS, and add the name ZFS. On the first node, you need to leave add storage checked. If on other node 2 and node 3, you need to leave unchecked. You need to leave tick for ZFS add storage on one node to allow Proxmox Cluster properly utilize ZFS pool between all the nodes. Single drive, that's fine. Compression or LZ4 is exactly the same. By default, Proxmox uses LZ4 for ZFS, so just leave that on, and 12 is fine by default. And I'm just gonna say, okay, that's great. Node 1 is creating ZFS for me, and that is done. So I have ZFS running, it's online. On ZFS on node 2, I need to go and click ZFS. I need to give the same name as I gave for node 1. Untick this, select everything, so basically just one drive and everything else by default, and click create. Now we need to do the same thing on node 3. So now I have all 3 nodes having ZFS created, but only ZFS showing on a node 1. To fix that, I need to click on a data center, storage, select ZFS, edit, and inside this drop down under nodes, I need to select 2 and 3 that nodes can utilize this ZFS pool, and click OK. And now in about a second or so, all the nodes will pick up the ZFS storage. So next thing, what we're going to do, I'm just going to go click on Alpine VM under hardware. I will select the local storage, 6 gigabytes, disk action, move storage, and I will select ZFS and delete the source and click move. So Proxmox right now relocating this drive from a local storage into ZFS pool. The drive has been successfully migrated in 22 seconds. If I close that, right now the hard drive located at ZFS. So now I can go and click on a replication as we tried to do before with the local storage, but right now we're running ZFS for this virtual machine. I'll click add, and we'll say this VM can replicate to PVE2 every minute. You can start from a minute and you can go all the way to basically first day of each year, so once a year. Depending on your VM size, you might need to increase this to 5 minutes or 15 minutes, but that means that the drive that will be replicated to node 2 will be 15 minutes behind what is actually node 1. For this demo, I'm just going to leave 1 because I know this is, I think, is 6 gigabytes or 8 gigabytes storage. Size of the drive is not going to take that long. And I'm going to leave this enabled. I'm going to click create. And now Proxmox is setting up the next sync for me to synchronize the drive from this into node 2. If I click on here, right now it's showing nothing because synchronization hasn't started yet. If I click on an Alpine VM, let's see, okay, synchronization is happening. I can see a loading wheel. And let's wait for this to finish. And here we are, we have this completed. The first sync happened in 21 seconds, and every other synchronization will start happening much faster because only changes will be synced across. So now if I click on a node 2, ZFS, I do have VM disk showing up here for VM 100, and the same one is available in node 2, in node 1, sorry. So now if I click on the VM, I'm going to say I want to add another replication. I want to replicate this to node 3 every minute and click add. So right now Proxmox Cluster will replicate virtual machine 100 disk from node 1 to node 2 and node 3 every 1 minute. And here we are, replication to node 3 finished in 16 seconds and the node 2 received replication in 4.5 seconds. No longer 21 seconds required, it's just because it was only the changes been synced. So right now if I'm going to right click on this VM, I'm going to say migrate to PV2, I'll get an error that's saying that you can migrate with a local disk. Please note that every time you're migrating VM, you need to detach everything like ISO files and everything else that's located inside local storage. So ISO drive, I'm just going to remove that. That's been removed. I need to shut down the VM to take the action. So I turn the VM off and turn back on, and right now ISO file no longer exists. So right now I can click on this Alpine VM and do migrate to PV2. It's telling me that the migration will take, disk might take long because 6 gigabytes migration, but they already have the actual replication happening. So I'm just going to go and click migrate. So request to high availability migration of VM 100 to node 2 task is done. So right now Proxmox high availability code behind the scenes will do all the migration for me. If I go to the actual logs, I can see the migration is happening. Double click on that and let's have a look. So migration started. Let's go have a look. It's already jumped to node 2. I'm just trying to quickly look how long it took for all this to happen in 21 seconds. So 21 seconds took to migrate the VM from one node 1 to node 2. I can migrate right now from node 2 to node 3 as a replication being set up. So what if one of the node dies? For example, if I'm going to go and right now force the node 2 to become offline, let's see what's going to happen. So node 2, I'm going to tell my system that node 2 is right now offline. So node 2 is brought to offline mode, and in a matter of seconds the icon, the green icon, will change from green to red, indicating that node is possibly dead. Here we go, this is changed. If I click on a data center and I scroll down to HA, in here I will start seeing information that node 2 possibly dead. Let's wait for this message to show up. Here we are, we have PV2, and in brackets it says all timestamp possibly dead. And voting happens in the background, and right now is going to be a decision made who will take node VM 100 to where. And after quite a long time, the actual VM finally got migrated to node 1. So node 2 is offline. Proxmox Cluster decides where the VM will go, and it went to node 1. Proxmox Cluster decided which node will take 100 and start hosting it, but you can restrict that a bit more. If you click on a data center, scroll down below the HA, one of the sub options is groups. And in here you can select, create the high availability groups. So for example, I want the Alpine VM 100 to be hosted only by node 2 and node 3. So if I click on a create, I'll give it the name Alpine and select node 2 and node 3. I can select a priority. For example, I know that node 3 might have more RAM and CPU power to run Alpine. So I'll say this is a priority 1. And PV2 has a bit of less RAM and CPU power. I'm going to say it's 2. That means that if node 3 dies, the VM will be hosted on node 2, but as soon as node 3 is back online, VM will be remigrated back to node 3. If I'll select restrict, it means that VM can only run on these nodes. It's never gonna end up inside the PVE1. And if I select no failback, that means that if node 3 dies, VM will be migrated to node 2, but once node 3 is up, VM won't be migrated back to node 3. So select like that. I'm going to say great. So right now Alpine group, and inside Alpine group we have node 2 and node 3, and node 2 is priority 2 and node 3 is priority 1. So first in line, second in line. Now under HA I can click on the VM, click edit, and I say add to a group. Yes. So right now I added that in. So VM is right now running on PVE 1, but group is insisting that VM needs to run on PVE 2 or PVE 3. As you can see, status migrate started. Proxmox realized that, okay, this VM has a group assigned and there is a special priority which node can run what. So technically, and I hope that's what's going to happen, is node, the PVE will be run to this, to node 2. I think, let me double check. Am I messed this up? Sorry. Yeah, 2 is bigger than 1. So yeah, priority is the other way around that I told you. So 2, if that was 3, like that. So right now Proxmox should decide that, okay, wait a minute. The node 3 has ID points 3, node 2 has points 2. So migration happens and goes in. So my apologies. Yeah. The bigger the number, the higher priority the node will take over by migration. So Proxmox is migrating right now VM from PVE2, and in a second it will migrate on PVE3, and as you can see, it's landed here. So migration happens, but it's still not best, not ideal, because first of all, it takes a bit of time to migrate between ZFS pools, between the nodes. Another problem is that replication. If this Alpine VM right now with only 6 GB of storage, if that was 200 GB, the actual replication will take forever to replicate and is not going to be ideal. It needs to be much faster and much better way. The other way that how you can get this working is with NFS. I do have NFS share ready for this demo, so let's get that working. I'm going to click on a data center, storage, add, choose NFS, and let's fill the details. So I'll give a name NFS. Server, will add the number IP address of my NFS server, and if I click on this, it's going to give me an option what I want to mount. I'm going to say demo cluster. Galaxy cluster is my production one, so I'm going to say demo cluster, and now I can choose what this attached storage will store. I can choose everything, so that's what I'm going to do. I'm going to say, yeah, I can choose everything and store in here. Note who will be able to use this. PVE1, PVE2, and PVE3 will be able to use this. I'm going to click add, and here we are. NFS share has been added. I can see this showing up under PVE1, PVE2, and PVE3. PVE2 and PVE3 still trying to decide if it's going to show up or not. Let's do a quick refresh, and here we are. All 3 nodes has access to the same NFS share. So right now, if I'm going to go to Alpine VM under hardware, I'm going to say I want to move from local disk. The VM disk I want to move from local storage into NFS. So I'm going to say NFS and move the disk. And while this is happening, I want to point out one thing that I'm going to click on a data center, storage. Under NFS, I do have option called shared. And that means that one single storage unit will be accessible via all the nodes at the same time. So while the Alpine VM is getting migrated, actually it's already moved, I'm going to click on NFS, VM disks. I do have access to this drive via PVE3. Same, I do have access to this drive via PVE2. And I do have access to the same drive via PVE1. So right now, migration is as simple as a right click, migrate, and tell where to go. And migration will start happening much faster than, for example, with ZFS. And here we are, output logs for my migration of VM100, which completed in 8 seconds. With ZFS, that took around 20-22 seconds to complete. But when you take into account that this VM is only 6 GB in size, it's going to take much longer to migrate via ZFS when you have a bigger size disk, where on this side, on this is just no problem at all. And Alpine actually jumped back to PVE3 for the reason that if I'm going to go to data center, I'll choose HA, and it's linked to Alpine group, which is forcing VM to only run on PVE3 and PVE2. So every time when I'm trying to migrate this VM to PVE1, like I'm going to do right now again, as I did before. So VM will go straight away into PVE1, migration happening, and migration will be completed in, show me the time, 8 seconds. But straight away, Proxmox Cluster HA, high availability, will decide, wait a minute, this is the wrong node, so it's automatically will start migrating VM back to PV2 or PV3 depending on the priority. And PV3 has a higher number, so it's going to land back to PV3. And that will happen in 8 seconds as well. So NFS works great, but with NFS there is a problem which is called single point of failure, which means that if my NFS or my Samba or my NAS dies, NFS connection stops working, if something happens to the NAS and that's it, NFS doesn't work anymore. Every single VM that is being moved to have a storage as NFS will stop functioning. So if each of these nodes will have 5 VMs in total between them, sorry, if every node will have 5 VM each and all VMs will be mounted to NFS, all of them will be stopped because NFS stopped. So NFS works much faster than ZFS, but it brings single point of failure, which is not ideal. The best solution for making sure that you have high availability VMs, LXC containers, and storage is to use CEPH. CEPH is an open source software-defined storage system that provides scalable and reliable storage solution for managing data across computer cluster. In a nutshell, every single node inside your Proxmox cluster will be responsible to make sure that CEPH is in sync. So all the drives will be in sync and your pool will be healthy. A couple of things to mention before going into a CEPH setup. First of all, I'm not the expert of CEPH, but I've been using CEPH setup on my main Proxmox server for about 2 months now. And I broke it so many times that I don't really want to admit how many times I did that. But I think I am at a position where I can give you an understanding how CEPH can be set up on your Proxmox. And in upcoming videos, I will give you a demo what you need to do if things goes bad. And next thing, what I want to mention that each node must have a separate drive for CEPH to fully function. In my case, each node has an additional 32 GB drives attached. 64 GB is being used for OS and everything else. An additional 32 GB drive is at the moment blank on each of the nodes. As you can see, node 2 has the same size drive and node 3 has the same size drive. Next thing is that you don't need to have same amount of drives on each node for CEPH to work. You can have 2 drives on one node and 1 drive on another node, as long as the drive size are somewhere around the same. What I mean by that is that if you have 2 nodes with 1 TB drive each and third node with 256 GB drive, you're going to have a bad time setting up CEPH. Well, CEPH will function, but not at the full capacity. Ideally, regarding with the storage for CEPH, all the drive needs to be best scenario, same size or very close. So let's start setting up CEPH. I'm going to click on PVE1 because I want this to be my initiator of the CEPH. So I'm going to click on PVE1 and inside the options list, I'll click on CEPH. And it will give me a message saying the CEPH is not installed on this node. Would you like to install it? I'm going to say yes. And I will pick the most recent version, REEF 18.2. And from Enterprise repository, I will choose no subscription. And I'll click Start REEF installation. It's going to open the command line and it's going to give me an option to accept installation. I'm going to say Y and enter. And right now I leave this installation going. It will take about a minute and a half, up to 2 minutes to get everything installed, depending how fast your Proxmox node is, how many RAM, CPU, and everything else. This depends on a lot of factors, how fast it's going to be installed. So I'm going to leave this going and I'll come back when this is done. And here we are, CEPH is installed. I'm going to click next. And now I'm going to need to start setting it up. Public network for CEPH, I'm going to choose the one network NIC that's available for me. If you have more than one, I suggest to choose the other one, not the main one that accesses the internet, but the other one to make sure that all the traffic that will happen between CEPH cluster nodes, which is going to be PV1, 2, and 3, will happen on another NIC. So the less congestion connection is going to be much better. But because I have my setup is only one NIC, I'm going to choose that. Cluster network, same as public, that's fine. Numbers of replicas and minimum replicas. Number of replicas represents how many nodes will be included in CEPH pool. In my case, it's 3 nodes, so I'm going to choose 3. And for CEPH to function properly, at least minimum of 2 needs to be online for CEPH still to function while you're sorting the third one. So everything else from your NIC down is just going to be default. Click next, and that's it. Installation successful, and it gives you basic information what you need to do next. You need to install CEPH on other nodes, create additional CEPH monitors, create CEPH OSDs, and create CEPH pool. So we're going to click next. And right now under CEPH, I have this page. Instead of showing me that it's not installed, I have this page going. And so far it tells me that I have one monitor, one manager, no information about read and write performance, and no OSDs in or out. So I'm going to click on PVE2. Under CEPH, it gives me an option to install CEPH. So I'm going to follow the same procedure. Ref as a version, non-subscription, install it, and it's going to give me an option to accept. I'm going to say Y and yes, and wait for this installation to finish. And here we are, we have CEPH installed on the node 2. I'm going to click next, and right now it gives me information that configuration already initialized. Once you're setting up the Proxmox cluster, there is a special file that's getting synced between every single node inside the cluster. And that file, sorry, not a file, folder. And that folder contains right now CEPH configurations. That's how the node 2 knows that configuration has already been initialized, because it's accessed that synced folder, knows that the file is already being created. So I'm just going to click next and finish. And now I need to do exactly the same thing on PVE3. But before doing that, as you can see, there's a warning saying that OSD count is actually 0, where it's supposed to be default as 3. OSD means drives not assigned yet. So we're going to do that as soon as I get the node 3 up and running. So click on node 3, install CEPH, and do exactly the same procedure as I done on the PVE2. And here we are, we have CEPH installed on the node 3. So I'm going to click next. Same situation here, node 3 knows that the CEPH configuration already initialized. So I'm going to click next. And now what we need to do, we completed point 1. So now we need to go and set up CEPH monitors, then OSDs, and then the pool. If I click on any node and I'll go to option CEPH, I'll see all the information showing up here. And I can click on the data center, then CEPH, and I'll see the same information here. So now let's start setting up monitors, managers, and then OSDs, and then a pool. I'm going to click on PVE1 or PVE2, doesn't matter. Click on a CEPH, and then drop down. If you can see that, you click on that triangle to reveal more. I need to configuration will show you all the configuration about CEPH. I highly recommend do not touch anything in here, otherwise CEPH will get broken. Under monitor, I need to add monitors. Imagine monitors as the security guards. They will keep an eye on the CEPH and make sure that everything is sticking nicely. So I'm going to add monitor 2. That's been added, and I add monitor PVE3. And here we are. I have 3 monitors running. One is still showing stopped. It's going to start running in a second. Here we go. So I have 3 monitors running. Manager is, imagine this like an overall boss. He knows how data needs to be synced and if CEPH pool is healthy. One monitor is fine, but better is to have 2. So I'm going to add PVE2 as a monitor 2, as a manager 2. And right now, as you can see, PVE1 it says active, and PVE2 is in standby. That means that it's ready to take over manager position if PVE1 becomes offline. But right now PVE3 is unhappy, so we're going to go and add PVE3 to be a manager as well. So right now PVE1 is a manager, PVE2 on standby, same as PVE3 is going to show up here on the standby, ready to take over. So if PVE1 crashes, it becomes offline, either of these 2 nodes will take over as a manager and will start checking if CEPH pool or CEPH data cluster is healthy. Let's click on OSDs. Imagine OSDs as a checkpoints. You create OSD. OSD is representing the drive. So you create the checkpoints where CEPH will store data and make sure that the data is even across entire CEPH pool. I will start doing OSDs from PVE1 because when you create OSD, ID number will be assigned. OSD ID number starts from 0. So PVE1 will have OSD ID 0, PVE2 will have OSD ID 1, and then PVE3 will have OSD ID 2. So I like to have everything in numbering order. So PVE1, CEPH, OSD, create OSD. It automatically will pick up the available drive. So I'm going to say, yeah, that's fine. I will not take encrypted OSD. In your case, you might need to have encrypted OSD. I will not keep that. I will not take that. Dry device class. You can choose. You can leave it as auto detect. I'm just going to choose manually. It is HDD. Is more for logs and how CEPH will treat each drive. Is no like super speed penalties depending which one you choose. I will choose HDD. If you have 2 drives attached to a node, one is hard drive and one is, for example, SSD on NVMe, you can start setting up like a cache drives to make sure that to make Ceph pool read writes much faster. As I only have one drive, I'm gonna choose HDD, create. Right now, Ceph is creating my first OSD. Let's wait for this to finish. And once it's done, it's not gonna show up straight away. I just need to quickly reload and reload again. And here we are. PBE1 has OSD 0. It's a hard drive, file store, and currently is in, but is down. That means that the Ceph is initializing this drive. So while this is happening, I can click on PBE2. As you can see, it's seeing exactly the same information. The Ceph configuration is being shared across each node. So on PBE2, create OSD, drive automatically selected. I'll just choose that this is a hard drive. I'm going to click create. So right now I have 2 OSD drives created. I'm going to click on PBE3 and do exactly the same thing. Create OSD, drive is automatically selected. It's a hard drive, and click create. And here we are, all my 3 OSD drives are added. OSD 2 belongs to PBE3, still in the initializing process. One thing to point out that, let's say each OSD is 1 terabyte in size. This doesn't make that you suddenly magically have 3 terabytes of storage. You have still 1 terabyte of storage, which is being spread out across 3 drives, and they're all in sync. If I right now click on any node and then click on a Ceph, I'll see that this right now is saying state is healthy. I have up 3, that is good sign, and the PGs is active and clean. I'll explain to you what PGs means in a second. But basically that shows that the Ceph drive Ceph OSDs are clean. Then we have 3 monitors, they're all tick, and we have 3 managers, they're all green tick. And right now it says that total combination is 95 gigabytes of storage, but again, it's just 32 gigabytes 3 times. So don't treat that as I have an almost 100 gigabytes of storage. So right now I have monitors manager created. I have OSD created. ZFS, I never touched this, so I'm not really sure what exactly this does. I'm going to click straight away on pool. So under pools, I'm going to click create a pool. And now I will give it a name. I'm going to call it Ceph. Size is 3. That means it's spread across 3 drives, and 2 drives needs to be at minimum online for Ceph to fully function. Then set a crush rules, a replicated rule. So it's going to replicate data across all the drives, and number of PGs. So currently set to 128. Imagine PGs as a token. For example, if you uploading a data, 1 gigabyte of data you're uploading to this pool. And for Ceph to properly replicate this drive across every single drive, it will ask 20 tokens. So you will end up with 108. And let's say the VM runs and is constantly reading and writing data to Ceph. Ceph requires 50 tokens to make sure that everything is running fine. Ideal sweet spot for home users to start is 128. And you can see here, PG auto scale mode on. That means that suddenly if Ceph runs out of all these tokens, it can automatically scale up. On my main Proxmox server, I started with 32 and it scaled up to 64, and right now it happily sits there. This number might go up and down during the initial VM process, initial VM setup, LXC setup, when you're doing a lot of stuff inside the Proxmox, especially where the data is stored on Ceph. But once everything settles down, this number will settle down to a comfortable number for Ceph to fully function. And the rest of the stuff I'll leave at default. I never change any of this information inside my Proxmox, so I'm not gonna give you, I don't know exactly what they do. Make sure add to storage is ticked. That's it. Ceph 3.2 replication rules 128. Click create. Ceph pool has been created, and right now, as you can see, it's showing up under node 3, under node 2, and it shows up under node 1. So all these nodes right now have access to a single Ceph pool. As you can see, it's 32 gigabytes in size. So let's move VM to this Ceph pool. I'm going to click on a hardware, under VM, hardware, and from local, I'm going to click on disk action and move to the Ceph storage and say move. So while this is happening, if I exit this out, click on any node, and then click on a Ceph, I can see read and write performance. So as you can see right now, a lot of things happening, and this is where PG is getting used. So pairing, active cleaning, and etc. Pairing and etc. is just going to go up and down constantly. And if I go down, I can see that information is happening. There is a writing at 12 megabits per second, and then 6.3 kilobits read. So Ceph is right now getting utilized because the data is being moved to Ceph pool. So let's see how it's performing. And in 31 seconds, the data was moved. I'm going to do the same thing with Ubuntu. You need to shut down LXC container before you move the disk. You don't need to do that with VMs. So right now LXC container is getting shut down. I'm going to click on this, wait for this to happen. Let's see if I can do that now. CEPH and migrate. And right now LXC container disk getting migrated. Straight away I can go and monitor CEPH performance. Redundant data, PG inactive, PG string, that's it. It is detected that it might be the inefficient way of, what I mean to say is not enough PGs available for data to be migrated. So it's doing all the necessary configurations to make that happen. So right now, in a matter of seconds, I think it's almost done. I will get the LXC container disk migrated to CEPH. And here we are, task OK. LXC container drive has been moved, so I can go and start that running from CEPH pool. So LXC container starts. Straight away you can monitor how it's performing. 100, pairing is 1. Read and write, so 4% of data is being used. Stuff is getting read and write going. That's it. So I have LXC container and I have VM running within the VM disk, and LXC container disk is stored in CEPH. So let's migrate the VM to another node. I'm going to migrate to PVE1. I'm going to say go for it. Migration is happening. So let's go and check how it's performing. Migration is being initialized and migration is happening. With NFS, it took, I believe, was 8 seconds. So let's see how fast that's going to happen here. It took 9 seconds. This is pretty much what I expected. Like I said, I've been using CEPH on my main Proxmox server for about 2 months. And before I settled to use CEPH, I've been using NFS for about a month and a half. And I've done a lot of testing between NFS and CEPH performance. And for my use case, NFS and CEPH performs pretty much exactly the same. But like I mentioned, NFS brings you a single point of failure, and it happened twice when my NAS decided to restart because of update. And on another occasion, the NAS just completely basically went shut down and turned it off. And that meant that every single VM, all my Pi-hole, Home Assistant, all my files, all my paperless documents, everything went offline because all the drives were stored inside NFS. The speed-wise for my use case, NFS and CEPH performs the same. But with CEPH, right now I have 3 points of failure. What that basically means that CEPH data is being spread across 3 nodes. Either these nodes dies, the actual Alpine VM, for example, will be automatically migrated. We can actually go and test this. I'm going to go and make sure that my node 3 is right now offline. And because CEPH is being shared across all 3 nodes, is byte zeros and ones perfect migrated between them. So as soon as this stops functioning, CEPH knows exactly when the cutoff happened on the drive. VM gets migrated and starts exactly where it left. Let's check how Proxmox HA is performing. This is dead, and right now it says that it needs to go. It's going to detect that is dead. It will confirm it is dead, and it's going to migrate right now depending on the group policy. And a group policy means between PVE2 and PVE3. PVE3 is died, so that means that VM needs to be migrated to PVE2. And actually, while this is happening, I want to show you another thing. If you, for example, right-click on LXC container and do migrate, you will see restart mode. That means that LXC container will have to restart, shut it down, move it, and then start as fresh on a new node. In this case, will be PVE1. With VMs, when you migrate, it goes online mode. That means that VM will be online and still accessible during migration. You might see a little blip in a connection when the actual migration happens. That split second when migration happens, it goes. As you can see, CEPH right now is complaining as well that the one OSD is down, quorum 1 and 2. So the quarter or third of the pool is down, one OSD is down, and it's degraded, and it complains like hell that something has happened, but still CEPH is functioning. So let's wait for Proxmox HA to migrate this VM. VM is migrated to this, and right now what I'm going to bring node 3 back online. So node 3 is coming back online. And right now, if I'm going to go in CEPH pool will detect the node is back. Proxmox will detect the node is back. And Alpine already getting migrated to node 3 because of the group policy that it needs to migrate to a higher number. As you can see, CEPH is getting healed in front of our eyes, and it's automatically getting all the stuff done. So it's almost everything in green. So that's it. CEPH automatically detected that the node is back with its OSD, and the healing started. And right now, in a matter of seconds, it should happen, everything in green. So this is green. This is still showing up here. That's fine. And at the moment, as you can see, everything is, well, is doing a pairing again. Yeah, so it's doing a cleaning thing. And that's it. CEPH will go and heal itself with all the data, make sure that what is written on OSD on this node and this node is exactly been copied to this, and all three drives are in sync. And my Alpine is back to node 3 because of the Proxmox high availability group, which tells the system that this VM needs to work only on PV2 and 3, and if PV3 is offline, move to PV2, and if PV3 is come back online, move it back. And that's it, and it's all ticking nicely. And CEPH is just going to carry on healing because the systems that I'm using for this demo are not fast enough. For CEPH, you need to have a bit more beefier nodes that I have here for this test. You need at least, I would say, 16 gigabytes of RAM in each node and a bit more cores than I have here. But as you can see, it does function with this system. Let's see how it's healing. Now it's still doing all sorts here and making sure it's all ticking nicely. Okay, let's wait. Here we go. Undersized. So it's gonna keep going and going and going until finally it gets healed. On my main Proxmox, after one of my mess up, it took about 3 hours to get everything healed and fully functioning. But right now PV3 still thinks that it's down. Anyway, thank you very much for watching. I hope you enjoyed this very lengthy video about Proxmox Cluster. Let me know in the comment section below what you think about this video. It took me a while to record this video, to be honest, so hopefully you enjoyed watching this video. If you have an idea, so you would like me to show you how one thing or other thing works inside the Proxmox, please let me know in the comment section below. I do appreciate every comment, every feedback, and if you found this video helpful, consider subscribing or at least just click the like button. All the information that I use for this video you will find in the description below the like button. And like always, I'll see you in the next video. Goodbye.